This is the planet in the solar system closest to hell, where even metals melt into liquid, and no form of life can survive. This lovely planet is Venus, with corrosive sulfuric acid clouds, temperatures nearing 500 degrees C, and atmospheric pressure strong enough to crush steel. Today, we're asterisk throwing you onto it asterisk so you can see just how brutal life on Venus really is. In our solar system, Venus is the third brightest object in the sky after the sun and moon. Its trajectory across the heavens once inspired countless researchers and poets. For ages, people thought it was a fast-moving star. It wasn't until the first telescope appeared that we realized it's a planet. Venus often glides across the night sky alongside the bright Jupiter, while Mars, with its reddish hue, is harder to spot. As Earth's two closest cosmic neighbors, when the Soviet Union first landed a probe on an alien world, in the 1960, their target was the beautiful Venus. Only later did we discover this planet is far from lovely. From the 1970s to the early 1980, the first probe successfully reached Venus' surface, a milestone in space exploration history. In 1975, Venera 9 sent the first direct images of Venus' surface back to Earth. In that moment, humanity's fantasies were shattered by reality. The cameras didn't capture lush jungles, but a barren plain of exposed rock, enter a dim, diffused sky. Thick atmosphere swallowed everything. Angular rocks dotted the landscape. If there was ever a tropical paradise, it had long been destroyed, leaving behind a desert of sharp or weathered stones, uniformly gray in tone. The ground was dry and dusty, almost like fired clay. No movement, no color variation, no signs of life, just the silent existence of a planet. Such extreme heat and pressure make life impossible. In 1982, Venera 13 sent back Venus' most famous image, a color panorama, showing the surface's monotonous brown-gray tones, and hazy atmosphere in clearer detail. The probe's own shadow loomed like an alien object over this familiar yet utterly strange terrain. These images were a scientific triumph, but also an emotional letdown. Every probe that landed in different spots revealed the same desolate scene. By the time NASA launched the Magellan probe to Venus in 1989, we knew optical cameras were useless here. Venus' atmosphere is too thick and opaque. Even the most powerful telescopes can only see a milky yellow barrier. But Magellan took a different approach. It used radar to see through the dense clouds, giving Venus a whole new image. Instead of traditional photos, it converted radar echoes into topographic maps. For the first time, Venus' surface was almost fully mapped, presented in false color images. Shades of color indicated terrain height, making geological composition and structure clear. What emerged was a world of intense geological activity, giant volcanoes, cracks stretching for kilometers, plains covered in lava flows. Most 11. Magellan was a breakthrough. Its images didn't show Venus' real appearance, but they revealed its true structure. The Venus Express mission showed another side of Venus. It was Europe's first dedicated space probe for Venus exploration, launched from Kazakhstan's Baikonur Cosmodrome on November 9, 2005, and entered Venus orbit on April 11, 2006. The mission lasted until December 2014, providing 8 years of valuable data for the scientific community. This mission focused on Venus' atmosphere, climate, and geological activity. The 1,270-kilogram probe carried 7 scientific instruments to study Venus' thick, complex atmosphere in detail. It revealed the first details of cloud structure, allowing us to accurately understand the chemical composition of atmospheric gases and their interaction with the solar wind. Venus Express detected a thin ozone layer in the upper atmosphere, captured stunning images of double vortices over the South Pole, and found evidence of ancient oceans, reigniting the fantasy that Venus might once have been a tropical green world. Sure enough, numerous simulations based on Venus Express data showed this is highly likely. Billions of years ago, before the greenhouse effect turned its surface into a furnace, our beautiful neighbor might have been a green, potentially habitable world. The probe also mapped a complete temperature profile of the southern hemisphere, showing that despite its extreme environment, Venus still has dynamic processes, possibly remnants of its once lush past. But on its way to the sun, Parker's solar probe, humanity's first solar probe, cleverly used Venus as a cosmic slingshot, using its gravity to accelerate. During several flybys between 2020 and 2022, it aimed its wide-angle imager at Venus, and the results caused a small sensation. This was the first time since the Venera missions that humanity obtained true visible light images of Venus' surface from orbit. The images showed a dimly glowing world, Aphrodite, Terra, and Artemis Chasma appeared as faint silhouettes. Despite the thick clouds, the surface's extreme heat emits just enough light to penetrate the dense atmosphere, making these images possible. The images aren't as clear as those of Mars or the Moon we're used to. Instead, Venus glows like a ghostly light against the starry background. Most striking is the luminous oxygen corona formed in Venus' upper atmosphere, appearing as a slender arc in the images. These images are not only technically astonishing but also emotionally moving. Whether it's a burning hell or a frozen wasteland, Venus still has the power to touch the human spirit. In 2023, scientists announced the discovery of potential biosignatures in Venus' atmosphere, a headline that shocked the world. To investigate these extraterrestrial life traces in depth, NASA immediately planned two ambitious Venus missions, Da Vinci Plus and Veritas, scheduled to launch between 2029 and 2031. Their goal is to probe Venus' atmosphere and surface with unprecedented precision, searching for microscopic signs of life. Both missions are part of NASA's Discovery program, aimed at promoting a new generation of low-cost, high science value space projects. The program hopes to use more affordable probes to solve unsolved mysteries within the solar system, at least giving us a more complete understanding of our cosmic neighbors. Da Vinci Plus consists of an orbiter and a spherical descent probe. The latter will penetrate the thick atmosphere to the surface, the first true Venus landing since the Venera missions. During descent, Da Vinci Plus will analyze the chemical composition of atmospheric gases, especially noble gases and trace elements, to reveal Venus formation history. It will also take high-resolution images of geological structures, focusing on terrain called tesserae, to search for clues to tectonic activity. Veritas is an orbiter that will use state-of-the-art radar technology to map Venus. This spacecraft, named Venus Emivity, radio science, INSAR, topography, and spectroscopy, Veritas, will create 3D maps of Venus' surface, measure rock emivity, and search for active volcanoes and tectonic movements. Its goal is to determine the extent of Venus' current geological activity, and whether processes like plate tectonics or subduction are still occurring. Researchers also hope to verify whether previous simulations of a tropical green world are true. Those early science fiction writers might not have been entirely imaginative. Additionally, there's Envision, the second Venus probe planned by the European Space Agency, set to begin comprehensive research on Venus in 2031. Its mission is to study the planet systematically from its core to its upper atmosphere, deepening our understanding of the interaction between geological processes and climate. Envision is part of ESA's Cosmic Vision program, and collaborates closely with NASA, which will provide key equipment like synthetic aperture radar systems. The mission aims to answer a core question: why do Venus and Earth, similar in size and location, have such different evolutionary paths? To this end, Envision will explore Venus' surface and internal geological evolution, assess its current geological activity, and search for evidence of ancient oceans. If oceans once existed, their traces may still remain in the oldest rocks. By the end of the mission, we will be able to more accurately determine when the extreme greenhouse effect began and why Venus eventually became a scorching inferno. Technologically, Envision is equipped with the most advanced instruments. The probe will carry multiple radar instruments to map the surface and shallow subsurface structures. 3 spectrometers will analyze the chemical composition of the atmosphere and rocks. A subsurface radar detector can probe up to 1 kilometer below the surface. Additionally, a radio tracking system will measure Venus' gravitational field to infer its internal structure.